okay questions, but who knows? We have to just see what we can do. So we have this diagram. So normally, depending on the information given, right, that's our first nomination, you know. So they've given us these two equations. One of them is an equation of an exponential graph because x here is on the exponent position. The other one is a log graph, which I mean, a log graph and an exponential graph, they are related somehow, because if you invert, the inverse of a log graph is an exponential graph. The inverse of an exponential graph is a log graph. So one or the other, that can be useful. So they said here, two graphs given, O represents the origin. Okay. And then the graphs have a common x-intercept. Okay. And then they have f. Wait, the graph of f has the y-intercept d. So as you can see, what the reason why we're reading what we're reading here is because whatever information they've given us here, if we do get stuck, this is where we're gonna come back to. And then here it says the asymptote of f and the graph of g both pass through A. So the asymptote of f and the graph of g both pass through A. So this asymptote here is the asymptote. It's probably the asymptote of our exponential graph, maybe. But yeah, because that's the graph of f, right? F is the exponential graph. And then they said here. So do you see the information here is important because they're technically giving us the equation of the asymptote, because we're seeing the y value here is a -1. And then here they say EBA. Where is EBA? EBA is a line perpendicular to the x-axis. So what they're trying to tell us is that the x value here is also going to be a 2. The x value here is also going to be a 2. Like that. See? So this is important. And then, so here it says, what do we have here? Let me just make this less bright. Right. It says the equation of f. What is the main question? We should determine the values of whatever. Okay, determine the value of t. So you equated the two equations here. No. You put in a coordinate, then you got t as a half. And then here the coordinate of c, you got it to be 1 coordinate 0. Fine. So here now they want us to they say that the equation of f of x minus k is equal to 0 has only one real root. What are all the possible values of k? So when they say one real root, they're referring to one x-intercept. You see, that's as blunt as we can put it. They're referring to one x-intercept. So since they're referring to one x-intercept, what we need to keep in mind is that k is basically moving the graph up or down. You see, this is basically a movement, a vertical shift. You see that?
Yeah.
Yeah. So this is just a vertical shift. So meaning the one thing you want to be careful of though.
Wait, that question is for calculus.
Not necessarily. This is more.
Are we done with the graph that we were doing? The one where we were making notes on that function.
Yeah. This question is still dealing with that graph.
It's different worksheets. Here, that question is for this graph. The one where it has F, R, A, Q, P, B, and S.
Yes. Because whatever f they're talking about is this graph of f here.
Here on this worksheet, question C says determine the value of P showing all working.
Are you saying this C is not the correct one?
No, that one is for calculus. That's on the calculus worksheet.
Oh, okay, wait. Let me maybe look for another C then. Oh, yes. Yeah. Ha. Oh, yeah, I get it now. Let me move this up. Check. Okay, well, that makes thing is different, but I think it's still understandable. So let's see here. Let's see. So with what we have to do, right? Using our sketch. Using our sketch, let's see what I wanted to do. Our sketch is here. I think top, yeah. So they're asking us to look at the value of P, right? Showing all workings. So the idea with P is, as you can see here, we have been given, we mentioned that we know what the asymptote is. The reason we know what the asymptote is because of this y value of A. So automatically we have Q. So our graph of f of x, right? So far it just looks like it's P to the power of x minus 1. So normally if you want to work out a variable, what you normally need to just do is to throw in a coordinate that the graph passes through. And we have a coordinate that the graph passes through. Because there's a y value that we have, there's an x value that we have. That's how you're going to work out P. Because remember, we have this common coordinate over here, which we just worked out. Or you worked it out here, you got it to be 1 coordinate 0. You see? So this same coordinate is a coordinate that you can use in this equation. You see it?
Mm-hmm.
Yeah. So where y is, you can throw there a 0. Where x is, you can throw there a 1. So 2p, well, that's kind of awkward because, oh no, it's not. The 1 is going to go over this side, it becomes a plus. And then divide both sides by 2, you have a p as a half.
Was a half.
Yeah. Coincidentally, it's the same as the other value, but it doesn't matter. So here, p is just a half. I don't know why I was not writing the stuff down here, but I can always just move it. So let us just do that. So this is so hot. Paste it down over here. Stay. Stay. There we go. There we go. There we go. So yeah, moving on, right? So determine the coordinate of T. So so now that you have the equation, you can see that getting the coordinates of T is straightforward, right?
Yes.
Yeah, because you're just gonna throw in an x value of 0. So the full equation here, we can actually just say therefore f of x is equal to 2. Here we have to put brackets, otherwise we're gonna mess things up. So here, since working out g where the x value is 0, can put here f of x, and just label it as f of 0, 2 half 0 minus 1. Anything to the power of 0 is a 1, right? So 2 times 1 minus 1, which is just 2 minus 1, which is plus 1. This. And here f is 0. There we go. So here, therefore, x value is 0, y value 1.
Okay.
There we go.
All right. Okay, I see what we did here. We used the C coordinate and then we subbed in the P value, which we just worked out now.
Yeah, because the big idea is your questions, they just basically fall on each other, or like they just stack up. So what you normally find in one question, you're going to now need to use in the next one, going on and on and on.
What?
Yeah. So the next one.
Next is calculate the length of AB. Yes.
Yeah. So calculate the length of AB. So AB is a point, is 2 points that are directly, above, one is above the other. So what can we do to get the length of AB?
Right.
Because this is what AB is. This is what AB is. So because
Can
remember,
we can't use the gradient formula. Well, we don't have the y value for B.
but they did tell us that this line is perpendicular to the x-axis. So if
Meaning
this line is
m
Mhm.
must equal to -1. I mean m, yeah, m must equal to -1 because it's perpendicular.
Well, not necessarily, right? The reason why they've given us this information, right, is because all they want us to do is to keep in mind that if you're going to work out the length of AB, the only thing you need to do is to compare the y values, because these points are aligned anyway, you see. So the y value up here minus the y value down there, you're going to get the length of AB, because it's the same x value anyways, you see. So that's what you want to remember. If you have a point over here and you have a point down there, as long as this is a straight line going downwards, for you to get the distance between this point and this point, you only just have to compare the y value here and you compare it to the y value down there. You see, so if this is like a 0, you see, if this y value here is like a 0 and this
Yeah,
one here is like minus 1, you see the
yes.
distance here is just 1 unit.
Mm.
Yeah, because of this line that is perpendicular to the x-axis. If this line was
Okay.
not perpendicular to the x-axis, then we would need to do something else. But because it's perpendicular to the x-axis, we can just compare the y values of our points. So here,
Oh,
our job is to actually just get the y value of b. Because once you get the y value of b, you can just say this y value, compare it to this y value, you'll have the distance of AB.
okay.
Yeah. So with that being said, right, what can we do to get the y value of b?
We use the gradient formula.
Okay? So I see you've been saying the gradient formula. Is it one of your favorite formulas?
Pardon?
I'm saying, is the gradient formula one of your favorite formulas?
Yes, the gradient and as well as the first principles formula with calculus and the quadratic formula.
Ah, I understand. So in this situation, right, you have to remember a straight line going upwards, we don't necessarily have a gradient of 1. That's not a line that has a gradient of 1. A line that has a gradient of 1 is slanted like that. See? So
Okay.
I think you're thinking of using gradient because you're maybe thinking a line going straight up like that has a gradient of 1, but it doesn't. You see, a line like that, technically, we can just say it has no gradient per se, you know. A line that's horizontal like this has a gradient of 0. You see, so that's a different story. But what you can do to get y is you have to remember point B is a point on a graph, right?
Mm.
Yeah, and that point we have its x value, right?
Yes.
Yeah, so what can we do to get its y value since it's a point on a graph? Can the equation of the graph help us? Because we have the equation of f,
Hello?
right? I'm saying,
Sorry,
can the
I
equation
lost
of
sorry, I lost you there. My Wi-Fi just cut off.
yeah, I was saying, can the equation of the graph help us since we have point B, right? We have its x value, but we're looking for its y value.
Yes, point B is on graph F.
Mm-hmm.
Therefore, we can use f of x.
Mm-hmm. Yes. So what are we going to do in the equation of f of x?
We are going to sub in B's x value.
Uh-huh. So we're subbing in an x value of 2.
Yes.
Mm-hmm. So this is a half squared, that's a quarter, right?
Mm-hmm.
This is like a half minus 1, which is minus a half. Which makes sense because you see, this is a point that is under the x-axis. There you go.
Ah, I see.
Yeah.
Okay.
Yeah.
Pretty simple. Oh.
Yes, ma'am. So now what is the distance of AB? Since we now have the y value here and the y value here.
Minus half. Minus. I got a half. I'm not sure if I calculated that correctly.
Yes, you did, because you're taking the higher y value minus the lower y value. You see, it's just like here. If you had a y value of 0, if you have a y value of -1, 0 minus -1 is 0. So what you did is 100% correct. -1 up there, I mean negative a half up there minus a -1 there. Your distance there is going to be +1. So here AB is equal to a half. So all that we were writing here, right? We can just maybe copy it and put it down to where our question is over there. So let's do this. Cut. And let's paste. Are you writing anything tomorrow? Oh, you say you are.
Yes, I am. Today I wrote Afrikaans. Tomorrow I'm writing Maths paper 1. On
Maths
Friday,
paper 1.
yes, on Friday I'm writing English. Saturday I'm not writing anything. Monday I'm writing accounting until 5 in the evening.
Ooh.
Accounting, my favorite subject.
Ooh. Okay, well at least that's some good news. Okay, let's see. The next one here says we should get the range. So what's your
Yes.
relationship like with range?
Range I am fine with. Minus half.
So then, okay, that's dope. So this question, how would you work it out? Like for example, they're asking for the range, right? So they're asking for the range of f. So what is the range of f? Are you there? Oh, it disappeared.
No.
Yeah. I was saying, so what's the range of f?
The range of f, well, I would look it into the y values of f.
Yeah. So yeah. So which y values does this graph go to?
It's less than negative a half.
The y values go away.
For graph f.
Mm-hmm. Because if they're asking us for the range of f, right? They are basically asking us which y values does this graph go to. So with an exponential graph, the lucky thing is what you look for is where the asymptote is, which is, as we said, this is where the asymptote is. Right?
-1.
Yeah. So our graph is up here, above
Yeah.
negative. Hold on. Yeah, our graph is up here above negative. Those are the y values that the graph goes to. It's y values that are above -1. You see that?
So it's just above -1. We don't include that -1.
Yeah, the reason why we don't include it is because it does not touch the negative. You see,
Oh,
range
okay.
range will be asking you what y values does this graph go to. We know that it only goes to y values that are above -1. Specifically, -1, it will not touch it because it's an asymptote. An asymptote is a line that the graph won't touch.
Yes.
So that being said, that's what we're going to say is the range of f here. Y is bigger than -1. Did I say 1? I meant to say -1. Where I wrote -1. Yeah, y is bigger than -1. And then what was that was all for that sketch, right?
Yes.
Okay. Let's move on to the next.